In today's video, I am going to teach you how to get quadratic equation using a formula in Excel. We are going to build a simple quadratic relationship from data points and then extract the coefficients of the equation using an Excel formula. First, type x values in cell A1. This is where you set up the column for your independent variable, usually x, so Excel knows what the numbers represent. Next, type y values in cell B1. This is the column header for the dependent variable, usually y, so you can keep your data organized. Now that the headings are in place, you will add the coefficient labels. Type coefficient A in cell D1. Then type coefficient B in cell D2. After that, type constant C in cell D3. These cells will hold the results of our quadratic equation, which has the general form y equals ax squared plus bx plus c. With the labels ready, it is time to enter your sample data. Fill rows A2 through A6 with numbers like 1, 2, 3, 4, and 5. These values represent x values at evenly spaced points. As you type, make sure you are entering them in consecutive rows so your data range is correct for later calculations. Next, fill rows B2 through B6 with the calculated curve values like 2, 7, 14, 23, and 34. These are the corresponding y values that match each x entry. Take a moment to confirm that each y value lines up with the correct x value on the same row. This matching is important because the formulas later use both ranges together. Now we move to the key part, where Excel will compute the coefficients for the quadratic equation. Type the code equals index line test B2, B6, A2, A6, 1 to 1 in cell E1. When you enter this formula, it uses the line test function to fit a curve based on your x and y data. The indexing portion then pulls out the first result from the linist output, which corresponds to coefficient A in the quadratic equation. After you have coefficient A, you will repeat the same approach for coefficient B. Type the code equals index linist B2, B6, A2, A6, 1, 2 in cell E2. This formula still uses the same underlying linist fitting, but it selects the second value from the returned results array. That selected value is coefficient B, which multiplies x in the equation. Then to complete the quadratic equation, you will extract the constant term, type the code equals index. Line test to B2, B6, A2, A6, 1, 3 in cell E3. This picks the third value from the line test results, which corresponds to constant C. With C in place, you now have all three components needed to write the quadratic equation clearly. At this point, you can look across cells E1, E2, and E3 to see the fitted coefficients. If everything was entered correctly, the quadratic equation should match the curve produced by your y values for x values 1 through 5. If the numbers look off, the first thing to check is that the x values in column A and the y values in column B are aligned row by row, because the fitting depends on that exact pairing, and that covers everything you need to know.